Hi, I'm Rob Taylor for PhotoTuts Plus, here today to bring you a DIY tutorial on building a Ringflash. The version I built is small for close-up and macro photography, but there's no reason you couldn't supersize it for studio use. As with all of my build tutorials, the idea here isn't necessarily for you to duplicate what I build, more showing you the path to bring your own ideas, materials, and requirements to the table. So for example, you don't want to splash out on this side glow optic fiber. No worries, just design a different diffusion method that works for you. This is my final product here with a foil reflector on the built-in flash for optical sync. You can see it again at the end, along with a few sample images, which are all straight out of camera. I explain my design decisions as I go along through the video. With that said, let's get going. Okay, here we go. We're going to use a 6-inch square of 3mm white acrylic sheet as the structural foundation for our ring flash. To mark out the ring, we'll need to use it. First we need to mark the center point by simply measuring halfway along each side and then ruling between opposite sides. I'm making a ring with a 75mm inner diameter and 125mm outer diameter to give about an inch all around the lens. This diameter will fit up to 72mm filter ring lenses, which is the widest I have. If you have any lenses you use for macro that are wider, you'll have to make a bigger ring. The 6-inch square acrylic will do up to 100mm inside and 150mm outside diameter, so just make it as big as you need. Here I've marked out the 75mm circle and need to do the 125mm circle. I set the compass as close as I can get to the radius of the circle, half the diameter, which in this case is 62.5mm. I set the needle to 0mm and put the point of the pencil between the 62 and 63mm markings. Now we're outside to cut out the ring. Depending on your particular method, you may or may not need to drill a center hole. I'm using a Dremel to cut around the outer circle, so I need to pin the center. No particular trick to this, just clamp and drill. I used the center hole to attach the circle guide, set the routing bit to just outside of the drawn line, and slowly pushed the Dremel along. It would actually be no more difficult to do this by hand with a narrow saw. Now we need to cut out the center of the ring, so we have to drill a wider hole to allow a saw blade to fit through. My Dremel base wouldn't allow me to cut such a small hole, so I used the scroll saw, which would have been much easier. Try not to let your fingers rub off the pencil markings. I had to go where I guessed was inside the line at one point, then sand it down later. If you're not confident with cutting circles, stay well inside the line and then file away the excess afterwards. Unless you're using a hole saw or something, it's unlikely that you're cutting perfect circles, so let's finish off the ring by sanding our cut smoother. This will also give the glue a surface to bite into. Once that's done, we have our ring. Now we're going to add the light guide that will contain the light from the flash and guide it forwards, toward and around the subject. I'm using aluminium flashing for a little more resilience, but it would probably be cheaper and easier to use thick card and aluminium foil. Just cut out two rectangles. The length of one is the circumference of the inner ring, and the other the circumference of the outer ring. Circumference is calculated simply by multiplying the diameter of a circle by pi. My inner circle has a circumference of about 236mm, and the outer circle is about 393mm around. You may want to add a little extra to use as a tab for gluing later. I made my inner rectangle 25mm wide and the outer rectangle 50mm wide. This should reduce spill and guide more light forward and inward for closer focusing. It's easier to draw all the cut lines before cutting anything out, and we need to know how big to make the slot to allow the light into the ring. This requires a combination of measurement and eyeballing. First, the measurement. We're going to measure the diameter of the fiber optic cable as a bundle without a shroud. If you bought loose strand fibers, this is pretty easy. Just gather them into a round bundle and measure the diameter. If, like me, you bought shrouded cable designed as neon lighting replacement, then you'll have to cut off this protective sheath to measure the fiber bundle. Once you have that measured, next is the eyeballing, where essentially I'm guessing at where I like the placement and angle of the fibers leaving the ring, and roughly how the light should propagate into the ring. To do this, I drew a 125mm diameter circle on some paper, and then designed a shoulder attachment exactly as you see on screen, where the light can enter into the ring, trying to maximize the brightness all around the ring. It's not much use if the light is concentrated on the side where it enters the ring. For this, we want as much light as possible to enter the light guide in order to be evenly spread, although if a little leaks and heats up one side, it's not the end of the world. Many macro photographers shoot with a 4:1 lighting ratio on their ring flashes by default. Once the shoulder is eyeballed, we need to know how wide it is where it meets the ring. To do that, we take our diagram and measure the angle shown on screen. If we divide this by 360, we get the fraction of the total circle it covers, and multiplying this fraction by the circumference gives us the slot's length. Now that we have the numbers from these, we can add the rectangle to cut out to the outer wall. Mine is 26mm by 70mm, so now I can scribe these dimensions onto the metal. After that, it's just a case of cutting it out. Now that we have our ring and reflective walls, it's time to put it together. This was quite tricky with aluminium flashing, but card will be much easier. After several attempts, the solution to holding the flashing in place while the JB weld was curing turned out to be copious quantities of duct tape, which could be fairly easily removed from the smooth surfaces the next day. The JB weld was applied with a thin strip of flashing as a spatula, gradually smearing it into place a bit like window grout. It's okay if you make a bit of a mess, since it wipes off quite easily when it's still fresh. Once I'd cleaned it up a bit, there was a reasonably neat beveled corner all the way around. I attached the inside and outside walls on different days, so that the used duct tape could be removed, and applying the JB weld wouldn't knock the previous wall out of place. Because the acrylic ring won't hold the outer wall in place, I JB welded and duct taped it at the right size first, so that it would be able to get bumped while fixing it in place. Holding the flashing in place with spring clamps didn't work very well at all. The outer ring is a little tricky to glue, but patience and some liberal dosages get the job done. As you can see, the JB weld is quite tacky and likes to stay stuck even to glossy surfaces. To wipe it off, a cotton swab or paper towel would probably be a better option than fingers. Next, it's time to return to our previous diagram to create the shoulder. To create the front and back, we need to transfer the paper design to a card template that we can trace around onto the flashing. If you're using card and foil, this part is much easier and you only need to trace once. To transfer the shape accurately, we need the measurements of the circles that form the shape as well as the shoulder itself. We take the height and width that we came up with earlier when figuring out the best shape, marked here as H and W. Then we need the radius of the upper circle, marked as R. With those three measurements, and knowing the diameter of our main circle, we can transfer the design to another surface. How you transfer these dimensions is up to you. I marked the 64-degree angle first, then built it up from there. I don't think this is really necessary though, since the overlapping of the circles at the right points will form the correct angles anyway. As long as the measurements are accurate, the order shouldn't matter. I then cut the template out and traced it onto the flashing. For the sides, it's back to the diagram quickly. We need to know what length the curved sides of the shoulder area are, which we can do in exactly the same way as the slot earlier on, finding the angle fraction and multiplying by the circumference. Mine were 42mm, but I made them 45mm to allow some wiggle room in the fitting. This ended up allowing the sides to grip under the outer wall, making the joint more secure. The width is the same as the slot that you cut. Mine is 26mm, so at one end of the shoulder I have a 26mm square, and at the other a 26 by 70mm rectangle. Once everything was cut out and trimmed to match each other, I had this. I bent the side sections slightly so they would hold the curve better once stuck in place. Using JB Weld to stick it together would certainly look better, but it would be extremely tricky and time consuming, so I opted for duct tape. The completed shoulder section got stuck onto the ring in the same way, and the result should look something like this. At this point there were only 3 things left to do: cut and install the fibre, add the filter ring, and create the flash shroud. Let's start with the filter ring. This is very easy, and a useful trick for attaching anything to your lens. Just buy a cheap UV filter, loosen the ring holding the glass in place by putting sideways pressure with a small screwdriver on one of the slots at the front, and then continue to screw it off. The only part we need is the main ring. This should be slightly larger than the hole in the ring, allowing us to set it in place and glue it on. Because this is a load-bearing piece, make sure to rough up the surfaces before applying JB Weld for maximum strength. I applied the JB Weld on both the inside and outside of the filter ring. The outside was actually more difficult, since you have to make sure that you don't get any glue in the outer filter threads and the ring isn't too thick. I also roughed up the ring itself to bare some metal and give the JB Weld some more surface area to stick to. Now we need to install the fibre. The way I'm doing it is to have 2 rings double stacked, with one slightly wider than the other for maximum light output. I cut the fibre in half and insert it into the ring and shoulder. You may need to use some pieces of clear tape here to hold it in place where you want it. You'll need some patience too, as the second fibre piece is quite hard to get in without messing up the first piece. Once it's all in place, you just need to trim off the excess fibre at the top of the shoulder. I used a pair of garden secateurs because I don't have a ratcheting PVC pipe cutter. They seem to work just as well and leave a nice clean cut, which is important to maximize light transmission. All that remains is to create the flash shroud, so we'll need to get everything in place to know how big to make it. I'm side mounting the flash on L brackets, but you could equally mount it on the hot shoe. Just bear in mind that if you do that, the shroud will either have to be angled or contain a 90-degree angle in it with a 45-degree reflector. It's partially for this convenience that I'm side mounting the flash. Once it's all together, the easiest way of creating a shroud is just to back some foil with duct tape and trim it so that it wraps around the assembly. I made this part up as I went along. I had no specific design going in except the pyramid shape. Ideally, we want to try to tuck it into the shoulder rather than mounting it over the top for minimum light leakage, but as long as it's tight enough, this isn't vital. Once the shroud itself is complete, I taped it onto the shoulder so that the flash can simply slide into place. Once this part's done, the whole thing is finished. And this is the final product. Now that all the hard work is over, let's reward ourselves by taking it out and shooting.